Good morning to all. Myself, Shoaib Pirzadeh, Assistant Professor, Department of Chemistry, Milia Arts Science and Management Science College, B. Friends, in the last lecture, we have seen different concept in thermodynamics. We have seen what is mean by system, what is mean by surrounding, what is mean by boundary, then types of system, open system, closed system, isolated system, homogeneous system, heterogeneous system, etc. Then we have seen extensive and intensive property. And then we have seen that is a types of process, different types of process. That is isothermal process, the process in which temperature of the system remains constant is called isothermal process. Isobaric process, a process in which pressure of the system remains constant is called isobaric process. Adiabatic process, a process in which total heat content of the system remains constant is called adiabatic process. Isochoric process, a process in which volume of the system remains constant is called isochoric process. Reversible process, a process in which that is a process which takes place in both direction, that is forward direction as well as backward direction is called reversible process. And irreversible process, that is process which takes place only in one direction is called irreversible process. Now, today we see in detail that is a difference between reversible process and irreversible process. Now we see first point in reversible process. So reversible process, it is an ideal process and takes infinite time. So reversible process is a ideal process and it takes, that is the infinite time, that is long time for completion. Irreversible process, it is spontaneous process. Reversible process is a spontaneous process and takes finite times, that is within a period of time, that is the reaction takes place. So it takes finite time, definite time. Next, in reversible process, the opposing force and driving force differ only by small difference. That is, there is a small difference between opposing and driving force. While in irreversible process, there is a large difference between driving and opposing forces. Next point, third point, in reversible process, maximum work done is obtained. That is, in reversible process, maximum amount of work is obtained. While in irreversible process, maximum work is not obtained. Maximum work done is not obtained. Now, reversible process is an imaginary process. Reversible process is an imaginary process. While irreversible process, that is a natural process. Fifth point, the process takes place in several steps. So that is, reversible process takes place in several steps or many steps, while that is the irreversible process takes place in single step. Now, in a reversible process, equilibrium exists at each stage. That is, in reversible process, there is equilibrium at each stage. While that is, in irreversible process, equilibrium is attained after completion of the process. So in reversible process, there is also equilibrium, but it is attained after the completion of the process. Now reversible process is extremely slow. That is reversible process. It is a slow process. So it takes, that is the infinite time. The irreversible process is fast. So it takes, that is the finite time. And last point, the course of process is can be changed. The course of process can be changed, and here the course of process cannot be changed. So this is the difference between, that is the reversible process and irreversible process. That is very simple. That is a reversible process take infinite time. It takes finite time. Here there is small difference in, that is opposing and driving forces, while in irreversible process there is a large difference between, that is driving and opposing forces. In reversible process maximum work is obtained. In irreversible process maximum work done is not obtained. It is imaginary process, it is natural process. It takes place in several steps, it takes place in single step. Equilibrium is exist at each stage in reversible process, while equilibrium is attained after completion of reaction in irreversible process. Reversible process is a extremely slow process, while irreversible process is fast. So this is the difference between, that is reversible process and irreversible process. Now the next is difference between isothermal and adiabatic process. Difference between isothermal and adiabatic process. So isothermal process, as already we have seen, that is isothermal process, which quantity remains constant here in isothermal process, that is temperature. Yes, temperature of the system remains constant in isothermal process, while in adiabatic process temperature varies or temperature changes. So temperature changes in, that is adiabatic process. Second point, in isothermal process internal energy remains constant. In isothermal process internal energy remains constant, while in adiabatic process internal energy changes. Third point, in isothermal process the system exchange heat with the surrounding. In isothermal process system exchange heat with the surrounding, while in adiabatic process the system does not exchange heat with the surrounding. Next, fourth point, in isothermal process system is not thermally isolated. System is not thermally isolated, while in adiabatic process system is thermally isolated. Now during isothermal process, that is internal energy remains constant, that is the value of delta is 0. So according to first law, what is the first law equation? That is Q is equal to delta E plus W. In this equation put delta E as 0. Then what we get? That is Q is equal to W. Therefore, Q is equal to W. Now, during adiabatic change, Q is equal to 0. During adiabatic change, Q is equal to 0. Therefore, what is the value of delta E? That is Q is equal to delta E plus W. Put in this Q is equal to 0. Then what we get? Delta E is equal to minus W. Now, total heat content of the system changes in isothermal process. In isothermal process, total heat content of the system changes, while in adiabatic process, the total heat content of system remains constant. That is, the value of H is, that is the 0. Now, next is, that is a concept of heat and work. Concept of heat and work. Now, heat is a form of energy. As already we have seen that is a as already we have seen that is a energy is nothing but capacity to do work, capacity to do work, and heat flow from higher temperature to lower temperature unless some work is done on the system. That is, heat always flow from higher temperature to lower temperature unless some work is done on the system. So heat does not flow from, that is, a lower temperature to higher temperature. It always flow from higher temperature to lower temperature. Now heat is denoted by Q. Heat is denoted by Q. Now when heat is absorbed in some process, in some reaction, heat is absorbed, or in some reaction or in some process, heat is transferred or heat is evolved. Now when heat is absorbed, it is denoted by plus Q. It is denoted by plus Q. And if heat is transferred or heat is evolved, it is denoted by, that is, minus Q. When heat is transferred or evolved from the system to the surrounding, it is denoted by minus Q. So this is the concept when we take, that is, a Q as positive. When we take Q as positive, यानी Q हम पॉजिटिव कब लेंगे, जब हीट एब्सॉर्ब होगी, और Q हम माइनस कब लेंगे, जब हीट प्रोसेस में इवॉल्व होगी. जनरली ये कंसेप्ट जो है न्यूमेरिकल प्रॉब्लम जब सॉल्व करेंगे वहां पे ये यूज होगा. दैट इज Q पॉजिटिव कब लेना है, Q नेगेटिव कब लेना है, एक्सेट्रा. So when heat is absorbed, we take Q as positive, and when heat is evolved, it is taken as negative. Okay. Now, different types of work. Different types of work. Or as already we have seen the definition of work. Can anybody tell me the formula for work? Work is the product of force into displacement, S. So different types of works are there. We see one by one with their formulae. Number one, mechanical work. So mechanical work is given by W is equal to F into dx. W is equal to F into dx, where F is, that is, the force, dx displacement. That is, the product of force into displacement is called work. It is called as the mechanical work. Now second, expansion work. Expansion work is given as W is equal to P into dV, where P is the pressure and dV is change in volume. dV is change in volume. So expansion work is given as W is equal to P into dV, where P is pressure and dV is change in volume. Now gravitational work. Gravitational work, as you have already seen in physics, that is W is equal to M into G into H. mgh, gravitational work, where M, what is M? Mass of the system. What is H? Height, and G, acceleration due to gravity. So gravitational work is given as W is equal to mgh, where M is mass of the system, G is acceleration due to gravity, and H is height. Now surface work. Surface work is given as W is equal to R into dA. W is equal to R into dA, where R is surface tension, where R is surface tension and dA is small area. So this is the surface work. That is, surface work is given as W is equal to R into dA, where R is surface tension and dA is small area. Now electrical work is given as electrical work, that is W is equal to epsilon into dq. Electrical work is given as W is equal to epsilon into dq. Now what is epsilon? Epsilon is nothing but dielectric constant. Epsilon is nothing but dielectric constant. dq, change in charge. dq is nothing but change in charge, and change in charge is equal to dq equal to, it is the product of current into time. Current multiplied by time, that give change in charge, that is the dq. So dq is equal to current into time. Current is denoted by I and time is denoted by dt. So dq is equal to I into dt. So these are the different types of work: mechanical work, then expansion work, gravitational work, surface work, electrical work, etc. Now, as we have seen, that is when that is a heat is absorbed, it is taken as plus q, and when heat is evolved, it is taken as, that is the minus q. Now similarly work, the work is denoted by ws. So work is denoted by w. Now similar to heat, here work is also positive and negative. Now when work is taken as positive and when work is taken as negative, we see, so the work is positive if the system is doing work on the surrounding, that is work is done by the system on the surrounding, then it is taken as, that is the positive. That is when the work is done by the system on the surrounding. You remember two words here, that is by the system on the surrounding, then it is taken as positive, that is W is positive. Now work is negative. When work is negative, if the work is done on the system, it is reverse of this previous one. That is, if when work is positive, by the system on the surrounding, and that is when work is negative, if the work is done on the system by the surrounding, then it is taken as, that is negative. Now similar to work, heat is gained or lost also depends upon the path followed by the system. Heat and work are interconvertible, that is heat is converted into work and work is converted into heat, so they are called interconvertible. Work done of a system can be calculated by knowing heat change during the process, but heat cannot be calculated from work. So this is the concept of heat and work. Now very important, that is we have to obtain expression for work done during reversible and irreversible process. Work done during reversible and irreversible process. So we see one by one, that is work done in, that is the irreversible process. Irreversible process. Now that expression is already we have obtained in 12th standard. So to obtain expression for work done in irreversible process, so we have to take here, that is consider that a gas is enclosed is a cylinder. So it is, that is shown in diagram, that is we have taken here a cylinder. This is the cylinder, and in this cylinder we have taken, that is the, this cylinder is filled with gas. Now it is fitted with weightless and frictionless piston. Now in this cylinder, that is a piston is fitted. The property of that piston is it is weightless and frictionless. So it is shown in diagram first. The initial volume of gas is V1 liter. Now the initial volume of this gas is V1 liter. So this is the initial volume. This is shown in, that is diagram. Second diagram, V1. V1 is the initial volume of the gas. Now the gas is expand. The expansion of gas takes place. Now how expansion of gas takes place? That is we have to move piston in upward direction. We have to move piston in upward direction. So by moving the piston in upward direction, that is expansion of the gas takes place, and its volume becomes, that is the V2. So it is shown in, that is third diagram, that is this piston here, this piston is moved in upward direction. Then what will happen? Its volume changes, that is initial volume is V1 and final volume, the volume becomes, that is the V2. So the gas is expand irreversibly and isothermally at an external pressure P. That is the pressure acting on the piston is denoted by P. So as we have seen, that is the piston moves in upward direction. So displacement of piston is given by dx. So the displacement of piston is given by dx. The volume of gas becomes, that is the V2. The volume of gas becomes V2. Now the work done during this process will be, the work done in this process can be given as, that is it is a mechanical work. It can be given as, that is W is equal to force into displacement. Force into displacement. So W is equal to, what is force? It is denoted by F. And what is displacement here? Displacement by the piston we have denoted by, that is the dx. So instead of this displacement, we can take here ds. So W is equal to F into dx. This is equation number 1, where F force exerted on the piston and dx is the displacement. Now this force exerted on piston, it is related with pressure. This force exerted on piston is related with, that is the pressure. That is, what is the definition of pressure, or what is the formula for pressure? That is, pressure is nothing but force per unit area. Force per unit area is called, that is the pressure. That is, pressure is equal to force upon area. So if we denote area by capital A, then P is equal to, that is pressure is equal to F divided by A. F is the force and A is the area. Now arranging this equation, or F is equal to P into A. F is equal to P into A. This is equation number 2. Now in equation 1, there is a term of force, that is F, while in equation 2 we have calculated the value of F, that is F is equal to P into A. So put the value of F as P into A in equation 1. Then equation 1 becomes, that is W is equal to, equation 1 is W is equal to F, but instead of F we have to write P into AS. This force is there, but from equation 2 we have calculated the value of, that is force, by using the definition of, that is pressure. Pressure is equal to force per unit area, that is F upon A. Therefore F is equal to P into A, and we have put this value of force in equation 1, that is W is equal to P into A into dx. That is, this is only this, instead of this F we have taken P into A, where P is the pressure, A is the area, and dx is the displacement, where A is area of piston, where A is area of piston. Now product of A and dx, this, the two quantity A into dx gives change in volume. From equation 3, that is, there are two terms A into dx, this A into dx. This A into dx is nothing but, that is change in volume, that is the dV. So in equation number 3, instead of this A into dx, we can write dV. So equation 3 becomes, therefore W is equal to this P. Now this A into dx is nothing but, that is the, this product is nothing but change in volume, and it is denoted by dV. Therefore W is equal to P into dV. This is equation number 4, where dV is change in volume. Change in volume, and it is nothing but that is dV is equal to V2 minus V1. That is final volume minus initial volume. It gives that is the change in volume that can be denoted by delta V. So delta V is nothing but V2 minus V1. V2 is the final volume while V1 is the initial volume. So equation 4 becomes W is equal to P into delta V, where W is work done in irreversible process, P is pressure, and delta V change in volume, or W is equal to P into V2 minus V1. W is equal to P into V2 minus V1. So this is the expression for work done in, that is, isothermal irreversible process. So problems also ask on this bit, that is, calculate the work done in isothermal irreversible process of a gas when its a initial volume, final volume, and that is pressure is given. So we have to, that is, use the formula W is equal to P into V2 minus V1. So here P is given, we have to put the value of P, then that is V2 minus V1, the initial and that is the final value of uh, volume is given. So put that value, and then we can obtain the work in irreversible process. Or sometime that is a work is given, initial and final volume is given in the problem, calculate the pressure, that is calculate the pressure in, that is, isothermal irreversible process when a gas expand from, that is, a 10 dm cube to 20 dm cube, again when against external work, that is work is given, that is the value of W is given. So we have to put the value of, that is, W, V2, V1. So by using this equation we can calculate the pressure. Now next, in these three conditions we have to see here, that is, what will happen during expansion of gas, what will happen when, that is, a compression of gas or contraction takes place, and third, what is the work when gas expand in vacuum. Now we see one by one. First, that is during expansion. During expansion, what will happen during expansion? Initial volume V1 and final volume V2. So which is greater here during expansion? That is V2 is greater, as V2 is greater than V1. During expansion, that is final volume is greater than, that is the initial volume, that is V2 is greater than V1. Then what is the value of delta V? For example, if V2 is 20 and V1 is 10, then what is the value of delta V? That is 10, and it is positive because V2 is greater, 20 minus 10. So the value of delta V is positive. Hence, the work done is also positive. That is, during expansion, that is V2 is greater than V1, and the value of delta V is positive, and as the value of delta V is positive, hence work is also positive. That is, work is done by the system on the surrounding. We have seen in the concept of heat and work, that is, when work is positive, when work is positive, when work is done by the system on the surrounding, by the system on the surrounding. So during expansion, V2 is greater than V1, delta V is positive. As delta V is positive, work is also positive. Hence, that is, work is done by the system on the surrounding. Now next, during compression or during contraction. What will happen during contraction or during compression? That is, during compression, that is V2 is less than V1. V2 is less than V1. Then what is the value of delta V? Suppose the value of uh, now suppose the value of V1 is 10 liters, suppose that is initial volume, and as contraction takes place, compression takes place, that is V2 is less than, that is the V1. V2 is, as the value of V1 is 10, then suppose the value of V2 is 5, then what is the value of delta V? What is the formula for delta V? As V2 minus V1. What is the value of V2? 5. 5 minus 10, that is the minus 5. So here the value of delta V is negative. Hence, that is during compression, V2 is greater than V1. V2 is greater than V1. Delta V is negative. Delta V is negative. Hence, work is also negative. As the value of delta V is negative, the work is also negative. Then work is done on the system by the surrounding. In previous one, what we have seen, that is if W is positive, work is positive when work is done by the system on the surrounding. Now in this case, that is in compression, that is V2 is less than V1, the value of delta V is negative. Hence, the value of work done is also, that is the negative. So work done is also negative. So which concept is used here? That is work is done on the system by the surrounding. So during compression, work is negative. That is work is done on the system by the surrounding. Now third, when a gas is allowed to expand in a vacuum, that is expansion of gas takes place in vacuum. In vacuum, that is, what about the opposing external pressure? Yes, can anybody tell me what is the value of pressure or opposing external pressure in vacuum? Its value is 0. That is vacuum, the value of opposing external pressure is 0. Then if that is P is 0. Now put the value P as 0 in, that is equation W is equal to P into delta V. So as W is equal to P, the value of delta P is, that is pressure is 0. So W is also, that is the 0. So in vacuum, W is 0. Thus, no work is done. No work is done during the expansion of gas in vacuum. That is in vacuum, no work is obtained here because that is pressure, the value of opposing external pressure is 0. So W is also 0. Thus, no work is done during the expansion of gas in vacuum. Such an expansion is called free expansion of gas. Such expansion is called as free expansion of gas. So these are the three, that is, cases. First is during expansion, during contraction, and that is in expansion in vacuum. So this is all about the work done during isothermal irreversible process of a gas. That is, we obtain expression, that is W is equal to P into delta V. I'll repeat again in short. That is, for that we have that is to obtain work done in isothermal irreversible process, we have taken a cylinder. That cylinder is fitted with gas, and in this weightless and frictionless piston is fitted. The initial volume of gas is V1. The piston moves, the expansion of gas takes place by moving the piston in upward direction. The final volume of the gas becomes V2. The pressure exerted on the piston is P. So then we have taken the mechanical work, that is displacement in this process is given by Tx. So W is equal to F into dx, this, where F is the force and dx is displacement. This force exerted on piston is related with pressure, that is P is equal to F upon A, and from this we have taken the F is equal to P into A, and from this equation 2 we have put F as P into A in equation 1. Then we get W is equal to P into A into dx, but the product of A into dx, it gives change in volume. So instead of this A into dx, we have put here dv. So W is equal to P into dv, where dv is change in volume. It is nothing but V2 minus V1, and it can be denoted as delta V. So W is equal to P into delta V, or W is equal to P into V2 minus V1. This is the expression for work done in, that is isothermal irreversible process of a gas. Okay. If any difficulty, any question is there, then please ask.